Hello, welcome to Pre-Algebra with Miss Betsy. Today we are going to be talking about probability, which is really what we're talking about whenever you hear the expression, what's the chance that it's going to rain today? Or you're playing a game, maybe Yahtzee or Farkle or something that involves needing to have particular combinations of dice when you roll them. You say, okay, what's the chance that I'm going to get a full house on this next round? On my next roll of the dice. So that is what we're talking about today, and that's called a probability. The text that I'm using looks like this. It is the first edition of Pre-Algebra for Christian schools, published by Bob Jones University Press. You don't even have to use a BJU Press book. If you're just interested in finding out what probability is all about, this is a good lecture to watch. So, I've got a lame joke for you today. I'm still in my piggy riddle book. What position did the piggy play on the baseball team? The piggy played snortstop. He played snortstop, which of course is shortstop on a baseball team. Even I know that, and I don't follow baseball. So, let's think about a little bit of vocabulary. Again, let's say that we have a spinner. This one has numbers on it rather than colors like Twister does. And these are numbered, just divided up into 4. And we have 4 options on that spinner. And we've got a little arrow in here that we flick. I can't draw that very well. But when we spin that spinner, there are 4 possible choices, aren't there? And while this isn't drawn perfectly well, I want you to see indicated here that each one of these 4 options are equally likely to result when you spin that spinner. So we have some definitions we have to know. When we spin the spinner, or when we roll the dice, or when we draw the card, whatever it is that we're talking about, that is called an experiment. And I wrote something incorrectly on my notes here. Okay, and what happens when I spin the spinner or when I conduct the experiment? I'm going to either get a 1, 2, 3, or 4. If I get a line, I'm going to draw it again. I'm going to spin it again. But the outcome, what results, that is called the event. What you get is called the event. And the terms experiment and event are important that you understand what those are when you are talking about probability. Because we have this expression here. It's P and then a capital E in parentheses. What do you think the P means? What's this lecture about? This lecture is about probability. So the probability of an event, or the probability of getting a 2 when you spin that spinner. Well, this probability we calculate by using a ratio. And this ratio is going to describe the likelihood that the event's going to occur. We spin the spinner, what's the probability that I'm going to get a 2? Well, I have 4 choices, right? They're all equally likely. So I have one choice, one possibility in 4 that I'm going to get the desired number. So what we have, this is a ratio. And that ratio, in the numerator, you have the number of possible outcomes. Number of possible things that happen when you spin the spinner. My mind went ahead, no. In the numerator, we don't want the number of possible outcomes. We want to have the number of favorable outcomes. What's a favorable outcome? That means that you get what you're looking for. Let's say favorable. You're playing this ancient antique game called Uncle Wiggily. I played it with my great aunt, and I enjoyed playing it. I bought it much later for my kids, and I thought, oh my word, this is the most boring game in the world. But we're playing Uncle Wiggily, and I needed to get a 2. So if I can spin this spinner and I can get a 1 or 2 or a 3 or a 4, and I need a 2, how many favorable outcomes are there? There's just one. I only want a 2. I don't want a 1, I don't want a 3, and I don't want a 4. So the probability of getting the 4, I said a 2. So the probability of me getting that 2, we're going to be able to calculate that. The numerator, you have the number of favorable outcomes. What do you think the denominator would be? Well, when I spin the spinner, am I only going to get a favorable outcome? No, I can have all of these numbers here. So this would be the total number of possible outcomes. Total number of possible outcomes. So back to my Uncle Wiggily illustration. I'm getting close. I'm going to beat Annie G. If I just get a 2, I want to spin a 2. There's only one favorable outcome. But how many possible things, how many possible results will there be? When I spin this spinner, I have 1, 2, 3, 4. So the probability of me getting that 2 when I spin that spinner is 1 in 4. The probability is 1 out of 4. Okay? We have a little bit more that we have to understand. Because if we were to convert 1/4 into a percentage, that would be 25%. So there's 25% probability that I am going to get my favorable outcome. What if we had a spinner that was 1, 2, 3, 4, it's my last turn, and I have to get a 5. What's the probability that I'm going to get a 5 on that? 0. There's no chance. Because if I only have one spin left and I need to go 5 spaces and I have 1, 2, 3, 4, it's not happening, is it? There is 0 probability. So if it is impossible to get what you want, if the possibility or the chance of it is impossible, that would be 0. How do we get 0? What's the likelihood that I'm going to get a 5? No chance. Out of 4, 0 divided by 4 is 0. There is 0% probability. On the other hand, let's say that I'm playing a game and either a 1, 2, 3, or 4 would be possible. Let me see how Then we say that if the probability of something is certain, it's a certainty that a particular outcome is going to result. That has the ratio there is 1. Let's say I want to have a 1 or a 2 or a 3 or a 4. 4 favorable outcomes divided by 4 possible outcomes. The probability is 1, or we think of this as being 100%. 100% probable that I will get either 1, 2, 3, or 4. 100% probable that we will not live forever in our earthly bodies on the earth. We're going to die. Okay, it's 100% probable. It is a certainty. So the probability of an event occurring is a ratio. It's the number of favorable outcomes, the number of outcomes that are desirable to you, divided by the total number of outcomes that are possible. So let's look at an example. Let's say that we have this spinner here, and again, I'm not going to draw the spinner part of it because I can't. And this is a particularly poorly drawn pizza. Let me try again. See if I can make this a little bit more even. We're going to have 6 possible choices on this spinner, and they are supposed to be evenly divided wedges. And that's just not happening today with my drawing. So how many equally spaced pieces are there here? There's going to be 6, but we're not going to do 1, 2, 3, 4, 5, 6. We're going to do 3, 2, 1, 2, 1, 2. So, just looking at this, which is going to be the least likely chance that you're going to get? The least common outcome? It's going to be 3. You've only got one choice, don't you? It's going to be more likely that you're going to get a 2, isn't it? It's like when you have these great big old spin wheels at a carnival or something, and you have a bazillion different choices of prizes, and you might have, you know, a giant prize here, a $100 gift card to someplace, and then you have a candy bar and a cookie and a candy bar and a candy bar and a pencil. You know, it's very unlikely that you're going to get that $100 prize. But back to this one. We want to calculate some probabilities of a particular result occurring. So what's the probability that we're going to have a 3? What's the probability that the result of our experiment is going to be a 3? How many possible favorable outcomes are there on one spin? We have 6 choices here. How many are favorable? There's just one. So you have one favorable outcome out of 6 possible outcomes. So the probability of you spinning a 3 is 1 in 6. 1 chance in 6 to spin a 3. What about the probability of a 2 being spun? How many 2s are there? You have 3 favorable outcomes. You have 6 possible areas that spinner can land on. So is your probability of a 2, 3, and 6? Well, yes, but this is a ratio. You always show this in lowest terms. So you have a 1 in 2 probability. Always reduce fractions to lowest terms. And finally, what is the probability that the result or the outcome of our experiment is going to result in an event that's a 1? The probability of a 1 when we spin, there are two possible 1s out of 6 possible results, gives us a probability of 1 in 3. Okay? I think that is really pretty straightforward. So go ahead and work on those. If you have difficulty, send me a text and I'll see you in class on Friday.